If a population appears to be growing by the same number each year, we would say they have what kind of growth? So the two options, it's either going to be linear growth or it's going to be exponential. That's the purpose of this question, is to help us distinguish the difference between linear growth and exponential growth. So it's going to be the same thing down here. One of these is going to be linear and the other is going to be exponential. So what is linear growth? Linear growth is if you start with a number, let's say there's 10 rabbits to begin with, and it goes up by a fixed amount, say like 5 rabbits every year. So that would be 15, 20, 25, 30, 35, etc. So every time it's going up by 5 rabbits. So if a rabbit population grows by the same number every time, that's what they're saying here, same number, that's linear. So this first one is linear growth. Now the other option is exponential growth. Things can also grow exponentially. How does that look? Well, let's say again we started with 10 rabbits, but it's going to grow every time by 50%. So it's going to multiply by 1.50. That's 50% growth, isn't it? Because remember how the growth formula works? You multiply the new amount equals the old amount times 1 plus the interest rate, right? So if the new amount equals the old amount times 1 plus 0.50, or actually probably you're used to, let me draw it the way you're used to saying it. It's 1 plus the interest rate times the old amount. So if the interest rate is 50%, or the growth amount is 50% times, I'll put the times in here, times the old. So in other words, the new will equal 1.50, or just 1.5 times the old. So that would be 50% growth. The new amount, the next generation is 1 plus r, where r is the rate of growth, times the old amount, which comes out to be 1.50 times the old amount. So if you take 10 on your calculator and you multiply by 1.50, you'll get 15, which is the same amount we got the second generation. So at first they kind of look the same. But let's keep going. What's going to be the next generation? We multiply by 1.50 again. I'm going to need my calculator at this point. Let's see. I'm getting 22.5 instead of 20. So it's a little higher. And then next, times 1.50 again. Or just 1.5. And it's 33.75. It's starting to pull away. Next, just keep multiplying by 1.50 or 1.5. Same thing. Now 50 compared to 30. Let's do one more. Multiply by 1.50 again. And now it's at 75.9375 rather than 35. It's more than twice as much. So this was the start here, right? We call that the 0th spot. And then this is the first generation of growth, second, third, fourth, fifth. So by the 5th generation of growth, if just adding 5 every time, linear growth, adding the same number every time, it only got up to 35. Exponential growth, they started the same, 10. The first generation was 15 in both cases, but the bottom one was multiplying the same number every time. In other words, growing by the same percentage, 50%. Half again, right? Half of 10 is 5, so it it grew by 5. But then half of 15 is 7.5, right? Half of $15 is $7.50. So it added $7.50 the second time. That's why it went up to $22.50. And then it added half of that amount again, and half of that amount again, and half of that amount again. It was growing by 50% every time we were multiplying by 1.50. The 1 was giving us back the original, and the 0.50 giving us the 50% increase. And that was faster growth, wasn't it? It went up to 75 by the 5th generation instead of just 35. Now it's twice as big, and it'll continue to explode. Exponential growth is explosive. And so our answer down here, if the population appears to be growing by the same percentage instead of the same number, that one's exponential, isn't it? So that's the difference between linear growth and exponential growth.